Hello and welcome to another kitchen lab. Today I ventured outside of the kitchen, although you can still see it behind me, and we're going to be looking at why and how we do experiments in science. You can, as always, follow along using the worksheet that is available in the link or on the website. Today you're going to need just a few things. You're going to need a pencil or a pen, a ruler, and some paper. Now, the most important thing that you're also going to need is a bag of sweets of your choice that come in different colours. They don't have to be sweets, but it makes it a much more fun and tasty experiment if they are. So following the worksheet, let's have a look at step 1. Why do we do experiments? In science, we do experiments to find out the answer to a question that we don't know. If the question's small and easy, that experiment might be quite quick and easy to do. But if the question's more tricky, like where do we come from, then the experiments might be more difficult and need to be repeated a lot of times. So we're going to start today by going through quite a straightforward question and show all of the transferable reasons as to why we do certain things in experiments. So the first thing to consider is at step 2. What's the question? For us, we're going to ask, how many are there of each colour of sweets in a bag? We need to have that question set out first so we can then properly do step 3, which is designing the experiment. When we design our experiment, we need to keep our question in mind and make sure that we design a way we're going to do it that means we're not going to influence the results with what we want the answer to be. So you might want the most common sweet colour in a bag to be red, for example. But we're interested in what the truth is, not what you want it to be. So we're going to design it so that even though you have that bias, that's not going to affect the outcome of the experiment. So what we're going to do is we're going to take an unopened bag of sweets. In this case, I have Starburst, previously called Opal Fruits. And we're going to make sure it's unopened because we know then it's not been tampered with and no one has come along and had a sneaky sweet while you weren't looking. And then we can open the bag and then we're going to pour out all of the sweets from this bag. And then we're going to separate them into their different colours. And now we're going to count how many we have of each sweet. Once you've counted them, you need to record the information or the data that you have found. You can use the table that I've put in the sheet, or you can make your own, or you could do something like I've done here where I've just drawn it by each of the piles of sweets. So we can see in this bag that I had 12 red sweets, I had 12 orange sweets, I had 11 purple, and I had 11 green sweets. So that's fine, and we can put that into a chart, but what we might want to do to present that data better to other people is we might want to put it in something called a graph or a chart in which we show how many different sweets there are in a visual way. That's much easier for people to look at and understand or interpret. So to do that, I'm just going to start a new sheet and follow the instructions that we've got on the worksheet. So we need to start by drawing a big L. Now I would use a pencil, but so it's easier on camera, I'm going to use a marker. So we draw a big L. Like so. And this is going to form the axes of the graph. So the vertical line that we have, this one going up, is called the y-axis. And the horizontal line going across the bottom of the page, this is called the x-axis. Now what we need to do up the vertical y-axis is put little lines or increments for us to fill up with the number of each colour of sweet that we have. So we know we have a maximum of 12 sweets, so this line needs to go up like a ruler to a minimum of 12. So I'm just going to put a line every centimetre, and it's going to be much taller than we need, but it means I've definitely got enough room to plot all of my data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm going to go to 13 just to go one above what I know the maximum is that's needed. Then we label that. And then we're going to say what that is, because if someone coming along looks at this after, they're not going to know what those numbers mean. So we need to say, this is the number of sweets. And now we're going to do a similar thing along the bottom on the X, the horizontal axis. And we need to just put the 4 different types of sweets that we've got. So we've got purple, red, orange, and green. Now you might want to make sure they spread out nice and evenly using your ruler, but I'm happy that I've just done that. And then we also need to give this a title as well. So this is the type or colour of sweets. Now what we're doing here is we're making a bar chart. And what we would then do at the next stage is we then just make a bar or a line up for each colour as to how many of each sweet we've got. But to show you what we're actually doing there, it's very easy that actually if we just pile the sweets there, this is exactly the same as what we're doing for a bar chart. So if I put all of the purples in, if these were the same diameter or the same width as each increment we've got up the side, which they are, you can see we've got 12 purple ones going up the side. And in theory, all we'd have to do now is draw around those sweets, and we'd have our bar on our bar chart. And then you could go on and do that for all of them. But you don't actually have to physically put the sweets on the bar chart. What we can do is we can just make a bar that goes up to the relevant number to represent the number of sweets that we found on each one. Now I've made an error here, okay, and that happens. That's not a problem. What we would do normally is we'd start this again for just the video. I've actually only got 11 purple sweets, not 12. So just for now, I'm just going to cross that out. We had 12 orange sweets, and we had 11 green sweets. Perfect. So now what you've done here is you've made a visual representation of the data of how many sweets you had in your packet of Starburst or whatever sweet you've used. This could then be shown to somebody else and they'd know exactly what you found. Now this might not seem very important for sweets, or maybe it does, but if it was something like how well a medicine worked, you can see how it's really important we make sure this is accurate and that other people can see what it says well and use that data or that information in whatever they're doing. So we've gone through quickly there how we're going to collect data, how we put that data together, and how we might show that in something like a bar chart. You could also use a scatter chart or a pie chart. There are lots of different ways of presenting data, and you just pick the best one for what you've got. So you can stop there if you'd like, or if you want to carry on, what we'll do is show how important repeating experiments is. So if we're going to carry on, to repeat this experiment, what we're going to need, and I liked this on my shop this week, is even more sweets. Again, we're just going to be doing the same method, so we need untampered bags. We need closed bags that haven't been tampered with, so that these repeats are fair and represent what you might find in the bags of sweets that you buy from the shop. Now, why are we going to do repeats? We've done this once. We know that you get 11 purple, 11 green, 12 red and 12 orange sweets. But we only know that for that one bag. Now we're going to make some assumptions here. We know that these are made on a sort of a conveyor belt like way. So they're all going to be relatively similar. But that doesn't mean there won't be slight differences between each bag, or what we would call variation. And the same's true, for example, giving a medicine to somebody. It might work slightly better on one person, it might not work very well at all on one person, and it might be very bad for another person to take. So if we only did one experiment with one repeat, we'd only know how it acted on that one person. Equally, we can't do this on every single bag of sweets ever. So what we do is we take a representative sample. We take a number of bags, or give the medicine to a number of people, where we're happy that if we take the average of what happened amongst those people, or the average of the number of sweets in each bag, we know roughly what is likely to be in the bags coming after that, or in giving that drug to multiple people after that. So that's exactly what we're going to do. And we'll need to record the data again on maybe a slightly more complicated table. So there's one on the worksheet that you can follow with, and I've just drawn out one here. We're going to have the number of sweets in each bag separately. So I've got 1, 2, 3 bags. Then we might have the combined total of all of those 3 bags, and then the average, where we divide the combined total by the number of bags that we had. So in this case, it will be the number of sweets in bags 1, 2 and 3 divided by 3 to find the average number of sweets we get per bag. And we've already got the first points of data. So we know that in the first bag we had 11 purple, and I can refer back to my graph here. We had 12 red, we had 12 orange, and we had 11 green. Just going to finish this graph off so it's nice and neat. There we are. So now we need to do the same for all of the other bags. So we go back to a previous step, open the bag, pour them all out. So what you might want to do to stop any error coming into your data is take the sweets from the first bag and put them somewhere else out of the way. I'm just going to pour them back into the original bag that they came out of. So now I won't be counting any of these twice and introducing error into this next count. So I've done that for the second bag now and separated them out, and we can record the data for that now. So you can see, again, we have 11 purple sweets. This time we have 11 red sweets. This time we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 orange sweets. So these two are different to the first one, so we can see some of that variation now. And we have 12 green sweets. So overall, we can actually see that this second bag had 1 fewer sweet than the first bag. You might feel shortchanged about that. What this shows, again, is the variance, the variation between different bags, and why it's important to take an average when we're looking at taking data scientifically. Just one person's account isn't good enough. Okay, we need to do it multiple times. So that's for the second bag, and now I'll repeat that for the third bag. So I've done that now for the third bag and put the data in the table here that we've got. So this time we had 12 purple, 12 red, 11 orange and 11 green, which is great because red and purple are clearly the best flavours. So then what we need to do is add them all up and get the combined number. So for purple, we've got 34 in total in 3 bags. For red, 35. For orange, 34. And for green, 34. And so the average would be these numbers divided by 3, which equal 11.3, 11.6, and then 11.3 for both of these. Obviously, you're not going to get 0.3 of a sweet, hopefully. So what we might say is that on average, based on this sample, you get 11 purple, 11 orange, 11 green, and 12 red. And not that we'll go into detail on this, if we're rounding to whole numbers, if after the decimal point we have under 5, we go down, and if we have 5 or above, we go up to the next number. But don't worry about that. We can just work with the decimals. So we can say on average we've got 11.3 purple, 11.3 orange, and 11.3 green, and 11.6 of red. That's the number of sweets we've got in a bag. Now, obviously that isn't a whole sweet, but it's because we're taking an average. And so that's as close as a number that you'll get between bags. And what that shows is that we do get that slight variation between the number of sweets we've got. And again, now what we might do is plot that on a graph so that it's easy for other people to see visually. And we can start with purple, and we can go to 11.3, which is 11 plus a third of the space to get to 12. And then for red, we'd go 11.6, which would be 11 plus 2/3 of the space to get towards 12. And then again, 11.3 for both orange and green. Now what this will show us is a far more accurate prediction of what's likely to happen over a number of bags. It doesn't mean that every bag is going to have 11.3, 11.6, 11.3 and 11.3 of each sweet in it, but it tells you that if you were to have multiple of these bags, over time, that's how much of each sweet you would get. And we can see there's that variation between them, and because these are so close, and we've only looked at 3 bags out of the millions that are produced, what we would then say, what we would conclude from this, but saying that our sample size was small, we would probably conclude that you get an equal number of coloured sweets on average in a bag. But that the reason you get these slight variations is because the number of sweets that goes into a bag can't be divided equally by 4, the 4 colours. So you will always get 1 or 2 extra of a particular colour. And that's probably just the luck of the draw. So that's what we're doing when we present data in graphs. We've asked a question. We've asked, how many of each colour do I get in a bag of sweets? We've looked at it once. We've recognised that just looking at one bag isn't good enough to apply that data to every bag of sweets we get. So we've done a few repeats so we can average out and get rid of some of that variation between bags. So we know now that roughly in a bag of Starburst, you get the same number of different coloured sweets, plus or minus 1 or 2, depending on the bag that you have. This is a really important concept that you can use in loads of different aspects of your life, and remember it when you're looking at data that other people show you on television or in a magazine. Have a look at their axes, see what they're showing you, and see if that matches what they tell you about that data. And you might find that sometimes it isn't, and they're not telling you the truth. I hope you enjoyed that kitchen lab. Do remember to like, follow, share the videos. I do this all for free, for benefit of everyone else, so please do share as widely as possible. Thank you very much.